Good morning, everybody. I hope you're doing well. Today we are going to be doing our 3D notes, which is solving one-step equations. And so we are going to start with this first problem here. But really quick, our learning targets are: I can solve one-step equations by adding, subtracting, multiplying, and dividing. I can solve one-step equations by squaring or finding the square root of a number. And I can check my solution to see if it makes the original equation true. So on this first problem, we have x plus 5 equals negative 8. We want to get the x by itself. We want to isolate the variable. And to do that, we have to do inverse operations. Now, in 6th grade, you guys did one-step equations, so we're going to go through these a little quickly. In 6th grade, your teachers taught you to put the line down the equal sign. You can continue doing that if you wish. I'm not going to force you to, and on most problems, I probably won't do that. But it is a helpful reminder that we need to keep our equations balanced. And what that means is whatever we do on one side of the line, or the equal sign, we have to do on the opposite. So this x plus 5, if we want to get the x by itself, we need to do the inverse operation, which means we got to do the opposite. Since it is a plus 5, we will have to minus 5. That will make these cancel out, and the only thing remaining is our x. But again, we got to keep it balanced. So if we minus 5 on the left, we have to also minus 5 on the right. And so these have the same signs. So same signs, add the 2. So 8 plus 5 is 13. And keep the sign of the higher number, the higher absolute value number. That would be the negative 8. So this is a negative 13. So x equals negative 13. Now, we could also check to make sure our answer is correct. You guys can end every one of these problems feeling confident that you're correct, because we can check our solutions, which is what the second or the third learning target was here, checking our solutions. All that means is we take our answer and we plug it back in and we see if it's correct. So to check our solutions, we would get rid of the x and put negative 13 there, plus 5 equals negative 8. And we would double check to make sure that this is true. So these have different signs here. We have a negative 13 and we have a positive 5. Different signs mean subtract. So 13 minus 5 is 8. And again, keep the sign of the higher number. 13 is the higher one here, and it was a negative. So this would be negative 8 equals negative 8, which means we did the problem correctly because we got a true statement. Negative 8 does in fact equal negative 8. So on today's notes, this is what we're going to be doing. We're going to be doing the inverse operations. We are going to do the opposite of whatever is happening to get to isolate the variable and figure out what the variable is going to equal. So let's look at it again over here. We have negative 4 equals n minus 11. So we always want to get the variable alone. So the n, we need to get rid of the minus 11. The inverse of minus 11 would be plus 11. And whatever we do on one side, we always do on the other. So those will cancel out, leaving just our n. And negative 4 plus 11, those have different signs. We would subtract them. 11 minus 4 is 7. Keep the sign of the higher number. 11 is higher. So we get this. Now, when you write your answers, though, I do not want you to write it with the number first. We should always rewrite it with the variable first. So n equals 7 would be the final answer here. And again, we could fact check that by plugging it back in. So we'd have negative 4 equals 7 minus 11. Well, 7 minus 11 is 11 minus 7 would be 4. So the opposite, 7 minus 11, would be negative 4. And so this is good, which means we did the problem correctly. I'm going to do one more problem with you guys, then I'll have you try the other 3 on your own. We're actually going to, oh, there's actually 6 here. Okay, new strategy. We're going to skip this second row because I'm going to have you do that on your own in a second. Let's move down to the third row. So negative 3x equals 36. If you forgot, whenever you have a number and a letter next to each other, this is always multiplication. And so to undo the multiplication, we would actually have to divide, which is what the fraction bar is here for. We're going to divide by negative 3. Make sure you're dividing by negative 3. Some people make the mistake of dividing by just positive 3. If you divided by positive 3 and not negative 3, the 3's would cancel out, and you'd be left with negative x. And we don't want negative x, we just want regular x. So you will divide by a -3. That way the negatives cancel out as well, leaving just x. And then 36 divided by -3, well, I know 36 divided by 3 is 12. And a positive divided by a negative will be a negative answer. So x equals -12. One last problem we'll do together, then I'll have you pause it and try the other 4 on your own. This is a division problem, n divided by -2. And so to get rid of the division, we multiply, which is what the dot means if you forgot. We'll multiply by the denominator. That way they will both cancel each other out, leaving just n equals. And whatever you do on one side, you always do to the other. I know 8 times 2 is 16, and a negative times a negative is a positive. So n equals 16 as our answer. These are the 4 types that we're going to be working with right now. I want you guys to pause the video and try to do the 4 problems that we have not done yet together, and then pause the video when you're ready. Or sorry, play the video when you're ready. Alrighty, so you should have subtracted 20 on both sides here because it is the inverse operation to get z equals -12. And on this one, to get the s alone, we would have to get rid of the -44 by adding 44 on both sides. That way those cancel. Your s is the remaining thing on the left side. And -1 plus 44 is really just 44 minus 1, which is 43. But make sure you rewrite it with your variable first. So s equals 43. Scrolling down a little bit. This is a multiplication problem because we have a number and a variable connected to each other. So we will need to divide by the coefficient. The coefficient is the number with your variable. So we'll divide by -9. That way the 9s and the negatives cancel out, leaving just v. And we always do it to the other side too. Negative divided by negative is a positive, so those will cancel each other out. 72 divided by 9 is 8. So v equals 8. And one last problem here. This one's a little weird because it has parentheses, but the parentheses are just grouping it all together. It doesn't really do anything here. So we still want to get the z alone, and it is currently dividing, so we need to multiply. If we multiplied by just 4, it'd cancel out the 4s, but we would still have that negative there, and we don't want the negative there. So instead of dividing by 4, instead of multiplying by 4, we'll multiply by -4. Now the 4s and the negatives cancel out because a negative divided by a negative is a positive, leaving you with a positive z. And whatever you do on one side, always do to the other. 4 times 12 is 48. So -4 times 12, -48. And flip it back around to have your variable first. Z equals -48. Alrighty, so these are more standard one-step equations, adding, subtracting, multiplying, and dividing. We also want to look at a couple more difficult ones that involve squares and square roots. So looking at this first one, c squared equals 25. We still want to do inverse operations to get the variable by itself. And so to get rid of the squared, we will have to do the opposite, which is square rooting both sides. A square and a square root will cancel each other out, leaving just the c equals, and the square root of 25 is 5. Remember, when you're square rooting something, you're looking for the number that times itself gives you 25. And so that would be 5 times 5, so the answer is c equals 5. Let's go ahead and skip one problem. Oh, no, sorry, we'll do this one. So this one's the opposite. Now it has a square root, so the square root of m equals 5. We need to do inverse operations still, which means we will need to do the opposite of a square root, which is the exponent 2. It is squaring something. Squaring a square root will cause them to cancel out, leaving just the m equals, and 5 squared is 25. So this is how you will solve equations involving squares and square roots. You're still doing the inverse operations. Go ahead and pause the video again and try to do these next 2 problems. Alrighty, so since there is a exponent to the squared, that means we will have to square roots, canceling out those, which gives you y, and the square root of 49 is 7. So it will be y equals 7. And on this next one, w has the square root, so we have to do the inverse, which is squaring it on both sides. 11 squared is 121. The square root of w squared is just w. And so we'll rewrite it as w equals 121. And one last part here, some error analysis. Harry solved some one-step equations. His work is below. State what he did wrong. I'll do the first one with you guys, then I want you to try the next two on your own. So x minus 4 equals 10. He did minus 4 on both sides to get x equals 6. The error on this problem is right here. Well, really, it's actually this right here. It was originally a minus. To solve these, you have to do inverse operations. And so the mistake is that he needed to add instead of subtract. Go ahead and pause the video and try to figure out these next two. Alrighty, so the mistake here was not the same one as last time. He had to divide 7, he times by 7. That's actually perfect. The mistake is that he didn't do it on both sides like we did on this original problem. He times the right side, but he didn't also times the left side. So Henry's mistake needed to multiply both sides. And one last problem. Square root of k equals 16, so they squared root both sides and got k equals 4. The mistake on this one was the square root of 16 here. You need to do inverse operations, which means you should have squared both sides. So the mistake needed to do inverse operations. So this mistake was essentially the same mistake as the first problem. They needed to do inverse operations. This is going to do it for our one-step equations. If you guys have any questions, please feel free to reach out to me, and I hope you have a great day.